So it's decarbonisation of heat events, and SunPeople is a ERDF funded project. So it's an Interreg project, cross-channel. So we've got project partners, myself, so I'm Dan from Plymouth Energy Community. Got John Selman, who's also on the call from Plymouth City Council. And then we've got two French project partners, Aloen and ASIO, who there's a lot of collaboration between all organisations through the project, which has been running for about 18 months now. And it's all about that cross-channel learning. How can we decarbonise heat, particularly through the combination of heat pumps and solar? For the event this afternoon, we'll basically, here's the agenda. Hopefully it would have been sent out to you earlier. There may be some slight changes that you'll see. But we're looking to provide some short case studies to demonstrate what can be done in terms of decarbonising heat. And in particular, so what key questions should we be asking installers? What are the key things to consider? So making it quite practical and just helping us become more educated customers. And also sort of how can we overcome some of those key barriers as well. So we'll go through that in the case studies. There'll be a chance to ask questions on each. And then we will have a panel discussion at the end as well. And thank you very much to our speakers for agreeing to attend today. I think there's some really interesting topics to be covered across a range of different technologies within the decarbonisation of heat. So I have James Kay from Mariners Guesthouse. We'll be talking about thermodynamic panels and how he's installed them as a small business. Dr. Juliette Jackson from Sea Dream Education will be looking at which is a really interesting project on sort of how she's retrofitted sort of home or new build with a ground source heat pump. George Gillow from Kenza, so we'll have the view from a manufacturer as well, looking at the ground source heat pumps. And then James Everington from Borehole, who have worked quite closely with us through this SunPeople project. Looking at key questions you need to sort of ask yourselves when you're looking at heat pump installation. And then in terms of the panel discussion, John Selman from Plymouth City Council will be hosting that, one of the project partners, of course. And then on that discussion, we'll have Mark Howard from Regen, Alistair Mumford from Devon County Council, and David Lewis from Southwest Energy Hub. And I'll be very much looking at the, drawing on the ideas from the case studies, but also looking at the bigger picture and things we need to, what are those long-term targets, how are we going to get there, and what do we need to do on a local level to achieve that. And where my slides work. Okay. That's flicked over for everyone now. Can you see my screen still? Yeah, cool, perfect. It's just mine then. That's good. Fantastic. Okay. So I'll give a. So as I said, I'm Dan from Plymouth Energy Community, and I'll give you a brief sort of rundown of the SunPeople project as we are at the moment, and then we'll get on to the case studies, and we can spend some real time on that, looking at those in a bit of detail. So the SunPeople project we started, I said, about 18 months ago. It's very much about trying to develop renewable heating options that can be delivered by ESCOs and community energy organisations such as PEC. And through the project, we're looking at the business side. So how can we develop a service-style business for heating in a similar way to how community energy groups have done that for solar PV, for example. Looking at the benefits of combining different technologies. So it could be heat pumps with solar PV. Could be looking at the thermodynamic panels that James will talk about later, or solar thermal. So we've undertaken a few feasibility studies with this in mind. Borehole have kindly done that work, and that's something we can share down the line. We can start to really identify what these key combinations are to make the projects more efficient in terms of their carbon savings, but also more financially viable for a site. It's been key through the whole project to engage with the supply chain, key stakeholders, potential customers, and we've had a number of events throughout. There's a couple of pictures on the side there, the screen, event we had all the way back in October 2019, sort of early on in the project when we were still allowed to travel. French partners came over to the UK. We looked at a few sites. We had some good stakeholder discussions. And we've continued that throughout the project. And we've had, you may have hopefully filled out some of the surveys that have been sent around, and then there may be some more of those to come, to try to really understand what people's concerns are, how we can encourage uptake, and how through this project we can really help push the decarbonisation of heat. And we really want to provide some resources for community energy groups at the end of this. So the project runs for a few more months, and combined with our cross-channel partners, we look to develop a kind of a guide, I guess, and resources for some of those community energy organisations, such as PEC, but also available for the supply chain as well. So there's other businesses, organisations, estates that may well find those resources useful. So in that pack of resources, we hope to provide sort of technical feasibility studies, for example. We can detail some of the best practice for looking at heat pumps, some of the other, so that's ground source, air source, thermodynamic panels, solar, etc. And we'll also have a sort of a dossier of legal templates. So if we're talking about heating as a service in particular, you'll need things such as lease, slightly boring, but you need things such as leases. You'll need heat supply agreements, EPC contracts, O&M contracts, and that's something we have worked with Anstey to develop those, and we can make them available to everyone to try and really kickstart these projects for some of these groups. And to work alongside that, we've also developed a financial model. So it's on me at the moment to try and tidy all of that up and bring that into a proper guide that's easy to use for community groups. And be very happy to run kind of workshops or something on how to use those resources as well. And through events such as today, we'll also have the chance to share case studies with you, both the ones that we've undertaken through the project, but also best practice ones from industry as well. As I said, we will send these slides out, and I have a link to Plymouth Energy Community's website on there, and there's a whole page about SunPeople and the bits of work we have done throughout. So a good place to go, sign up, and keep up to date on the details. So are there any questions on the SunPeople project before we move on to some of the case studies? I'm aware of time, so I'm trying not to take up too much myself. But let me just unshare my screen. Doesn't like that. Okay, I think it's because I'm on the spotlight thing. So cool. If there are no questions on the SunPeople, then we can move on to the case studies. And I think our first speaker is James Kay from Mariners Guesthouse. He's got a really interesting case study on the use of thermodynamic panels, particularly in looking at domestic hot water usage. So James, if you're good to go, I'll pass on to yourself. You're on mute, James, I think. So.
Not now. Is that okay?
That's perfect. Thank you.
Okay. Right.
So,
Good afternoon. Just like to say this is the first time I've done this, so bear with me. I've not done anything like this before. Obviously, I run a guest house in Plymouth, a 9-10 bedroom house, and 5 years. I worked for Princess Yachts for a while, and my wife was a dental practice manager. And we got into the guest house business, and I thought we'd start making some sort of a unique selling point for us. So I went down the route of looking at anything green. We joined Green Tourism, and they pointed us in these directions. So what we ended up with is we've done solar batteries, got electric cars, LED lights, and we've just installed these solar thermal panels. It's really a unique selling point that we wanted to push because we wanted to be at the forefront of the green ecotourism side of it. because it's not going to go away. It's going to be here forever and get stronger. So we thought we'd try to be on the cutting edge. So we installed these panels just after Christmas this year. And so far, I think they've been very successful for us. Even though it's quiet, it's still been very useful. I installed 2 systems. They're based on the reversible refrigerator. So you've got panels with halogen gas running through at like -20 there or thereabouts, and it absorbs the heat from the atmosphere, boils the gas, and then it goes back into a condenser and thermally exchanges in the water boiler. What I've got is 2 systems because I wanted one as a low use, and then one when we're on full use. So I've got 2 250-litre water tanks upstairs with 2 thermodynamic panels. Hopefully you might be able to see these pictures. Not too bad. I can get them close enough to you. I don't know whether you can or not. Not really, no. I'll leave those. So what we've done, I've fired one system up, which is on the right-hand side, and that runs 24/7. All it runs on is a fridge motor, which roughly draws about 800 watts of energy. And that energy I compensate with the use of solar battery. So basically, I'm getting the water for free, which is ideal from a business point of view. It heats up to about 55, 60 degrees, which you may think, oh, Legionella might be a problem, but it has a disinfector on it as well, which automatically heats the water up above the 65 degrees, I think it is, for Legionella. So from a safe point of view, it really is ideal. And these systems, I've spoken to the company that installed it, and they install it in care homes and hotels across the country with quite large volumes. The actual system took a day to install. One of the most expensive parts was putting the scaffolding up, which is about £500. But apart from that, we're just about there, and I'm still progressing and studying the system as we go week on week, and so far it's looking very favourable because it's cut our gas usage down by probably 60-70% at the moment. So I only have to run the radiators and our cooking gas. So eventually I'm looking to get rid of the gas totally, because obviously I think it's in 2030 that they want to remove gas from the system as far as possible, or the hydrocarbon gas, should I say. Apart from that, I think I'm about there. Yeah, I think it is. The company we use is actually based in Portugal. There are a number of countries based in the UK, which I did a survey, and I had quite a large range of quotes off from them. But the best one that came out with the most consistent record was a company called Engie, as I say, based in Portugal, and they've been going for like 30 years. So they've got a good background, and they've installed all over the world. So I used the UK arm of it, which is based in Taunton, and they came down and did the surveys for me and got everything done, installed it, and they employed a third-party subcontractor who was very, very good. I was very impressed with him. I think that's about it. Okay.
No, that's perfect. Thank you very much, James. And I mean, we've got a bit of time for questions as well, if anybody's got any specific questions. So John's asked, have you got an idea of sort of approximate costs for the system, so for the panels and for the installation? For a single system, one tank and one panel is around £4,000. And have you got, I guess you installed it over winter, so you've actually had it running over the cold months.
That's right.
Well, and does your hot water, domestic hot water, vary much seasonally?
As in usage?
Yes. Yeah.
Oh, absolutely. Yeah. In the winter months we're quiet, so that's why I only use one tank. And then when we go to the summer months, when we get high usage, I go to 2 tanks and 2 panels.
So this kind of technology actually matches your demand pretty well in that It's useful. As I said, please feel free to type any questions into the chat box, or you can use the raise your hand function as well.
But also, yeah, forgot, Dan, can I say something?
Yeah, absolutely.
Also, these panels do not have to be installed outside. They don't have to be in the sun. You can install them in like an attic room in a very small area. So they're not obvious and they're not noisy either, like other systems where they can be a nuisance. So these are very, very quiet. As I say, they only make the sound of a fridge motor, and that's it. Everything else is quiet.
So you've installed them in the attic as opposed to on the roof, for example.
I haven't.
Okay.
Yeah.
Got a couple of questions in the chat for you. So let me get to the first one. So from Adrian, how do thermodynamic panels differ from air source heat pump?
They're quiet, basically, compared to air source heat pump. The actual exchange, I'm not sure how an air pump works, but for the thermodynamic panels, it's basically the temperature difference between the minus 23 gas, halogen gas going in, and the external temperature heating it up to turn it into a gas, and then it turns it back into the system, and then condenses and heats the water at the same time.
Yeah, I mean, it's quite well, it works for radiation, doesn't it? It's solar based effectively, as opposed to, or heat based, I should say, as opposed to taking air temperature.
It works both, actually, Dan. You don't have to use the sun directly.
That's perfect. And so, John, would you recommend for normal domestic or just where there's high hot water demand?
Oh, the system, I would say you can use it on either side, to be honest. We use high volume, so I've got two systems in. You can adapt your system as to the size of how much water you want to use. I've got like 250 litre tanks. They do them at 125 litres, so for a normal house. So it is 24/7 heat available. It's not on demand, it's there.
I mean, that's really helpful. And I guess your B&B is, if it was a domestic property, it would be very large, but we're not talking a massive building here in terms of, commercial scale. This is certainly very replicable. So there's a question around maintenance, which is quite an interesting one, and one I'm sure many people have. So what kind of maintenance considerations are there with the thermodynamic panels as opposed to other heating options potentially, or in fact what you've replaced?
Right. Okay. All we need is a yearly look at them. That's all. The only other thing is we have anode that have to be replaced every 2 years. I've forgotten the name of them, but they're magnesium anodes that you put into the water tank to stop everything clogging up. So that's about it. We don't have any regular maintenance on them at all. So
it's pretty low maintenance, and I guess from a business point of view, that's always a massive bonus. And certainly, if you're anything like me, that's very useful on residential as well. Okay, in terms of question from Elliot, where are the these water tanks positioned in your building?
All right, they're right in the attic, close to the thermodynamic panels, because you need to have these water tanks within 10 meters of the panels, otherwise there's too much heat loss exchange between the panel and then going to the condenser.
I guess sort of tying that back to the question around, or the point around residential as well, that works quite well because within 10 meters, that's quite achievable on most residential properties. So just a question about the usage. What is the main use of your hot water and heating?
The hot water is basically purely showers, and for the customers and having shaves and whatever in the morning. That's it. That's all we do.
Yeah, so that's perfect. So John, I don't know if you had anything further to say on the difference between thermodynamic panels and heat pumps, because I know you've got a question, put a point in the chat there. Do you want to come in on that, John?
I just emphasise that the collectors. My understanding is that the collectors can be in the loft space.
Yeah.
So which is quite handy for a lot of houses. But they do have a small. The heat pump's quite small, isn't it? But they do have a small heat pump attached. But generally, I think the advice is that it's focused around hot water rather than space heating, isn't it? Is that your the advice that you've got, James?
Yes, it is, definitely.
Yeah, but it's good to have an example because for a while they weren't covered under the RHI, and there was sort of a question mark around them. But they've been around for quite a few years, so they have, but they're not commonly used in the UK that much, are they? So it's quite good to have an example in Plymouth locally.
Yes, yes, there was a lot of bad publicity about them, sort of in the 90s and early 2000s. A few, dare I say, rogue companies were set up and abused the system somewhat. So,
yep, still here. John's gone. I'm back to mute. I think just one more question in the chat, which I'll just pull up. So, is this viable as a full kit as opposed to separate elements? And what sort of scale are they made at? What scale have you looked at, and did you think, oh, I could go larger, smaller? I mean, we've kind of covered residential.
Yes. Oh, yes. The UK manager for the company comes around and assesses the system and advises you as to what you should put in. And this is what the system he came up with.
No, that's really helpful. And I think if you're happy to share that with us, James, I can maybe contact details for that company and stuff, so we can follow that up. And if people are interested, we can find out a bit more, and we can send that out to everyone. Yeah,
and if anybody wants to come around and have a look at the system in use, welcome anytime. Obviously, a guest house, so I'm here 24/7. So if you want to come and stay, you're quite welcome to.
I'm sure you have. Yeah, I mean, I did have a little look at your website earlier, actually, and the sort of green agenda that you're pushing there, and that's a really good thing. And I think particularly with news coming out from the government today or yesterday around accelerating that decarbonisation program, then this is something that we really need to be looking towards. So yeah, really exciting to see that kind of a project taking place locally. So thank you very much for that, James. I think, look at that, spot on time. Well happy. Fantastic, thank you, James. Okay. So now to sort of take a slightly a new technology and a slightly different project, but I'd like to invite Dr. Juliette Jackson to discuss her project that she's done on sort of retrofitting her home and putting in a ground source heat pump, and honestly, loads of really exciting stuff to talk about there. So if I pass things on to you, Juliette.
Excellent, thank you. Can you hear me?
Yep, that's perfect.
Okay.
Thank you.
And I'm going to share, hopefully. Okay, so can you see we built a house?
We can, yes.
Excellent. Right. I won't do slideshow because I think I might lose it, so I'm just going to go down like this. So yeah, we built a house. So Kat sent across some questions that I was going to try and answer throughout this little mini presentation. I put some pictures in because it will help me to talk about it. And yeah, we've got a new build. It's very different. It's an upcycled water tank. But new builds, in my opinion, present the ideal opportunity for a heat pump. And with some research that we did, we found that they last longer if you have 3-phase electricity. And if you're asking the questions, what low carbon heat technologies are most suitable for me? Well, ground source heat pump needs lots of garden, lots of space if you go vertically, but you can actually go horizontally if you're using a borehole. We've also got air source in the family as well. So my equivalent of parents, I've got 3-bed semi in Scotland, and they've got an air source heat pump. So bearing in mind it's Scotland, and I thought, man, is that going to cope with the cold? It does. It's going really well. What information should I ask from an installer? Well, if you do as much research as you can on the internet, and also talk to people that have the technology that you're interested in. So, for example, when we knew we were going to have a heat pump, we wanted to know how noisy it was and how big they are. So we asked the local heat pump installer if he could arrange for us to see one, and that actually had an impact on us. And we decided not to put it in the house, but actually make a little area for it outside the house. So I'll show you some pictures of that. And should I improve the energy efficiency of my building first? Definitely. And if it's a new build, make it as energy efficient as possible. So we've got low emissivity e-glass, loads of insulation. It's airtight house with the mechanical heat recovery ventilation. So it's very much about having as little loss as possible. So this is our tank. This is what we brought. It's our hobbit hole. It's 2 chambers, just with a wall in between. And that's when you remove all that earth, you have a steel reinforced concrete box, which we started to put the doors and windows in. So cut the doors and windows in to that box. If you note these vents at the top as well, you'll see those later on. We're set in 1/2 an acre, and it's a brownfield site. But it still took us a year of planning meetings before we were granted planning permission. They told us quite early on that we were going to be allowed to build a house, but there was lots of to and fro over the design of the house. So yeah, holes cut in the tank, and then we've got insulation on the inside and the outside of the tank itself. And then we've got 2-story new build adjacent to the tank and across the roof, across half of the roof of the tank. So inside we've got the underfloor heating, which we watched YouTube to see how to do it. When we had the concrete screed people come to pour it, they said that it was the best prepared floor that they'd ever seen. All these pipes go to these 2 manifolds. Well, there's one here and one downstairs, one upstairs. Pressure testing system before the liquid screed's poured. So these are just the stages in our building. And then outside, we've got the slinkies into 1.5 metre trenches. I can't remember what it actually had to be, but this is suitable for this site. It was 1.5 metre trenches with 1.5 metres between the trenches. I think that was partly determined by the size of the digger. The further apart the spacing, the better. Also, the wetter and the clay ground, the better. So we've got a mixture of clay and shillet, so it's pretty good. We've got 3 separate slinkies, each 500 metres, and they go into the manifold. The slinkies, as I'm sure you know, filled with a mixture of water and glycol, essentially antifreeze. Just a view of the slinkies. That's our sewage treatment plant in the distance. Here is our outside pump. So it's actually 2 pumps. One is doing the hot water and one is doing the underfloor heating. And there's a zoomed out picture there you can see of the house with the size, give you the scale of the heat pump house, heat pump container. And this is the house from the front. we did plan to have solar panels, and the roof is pitched at 30 degrees and positioned, orientated south facing, but we decided not to have solar panels actually, although we are now thinking of having solar panels on the roof of the garage, that's detached garage next door there. We've currently got some solar thermal water panels, but they're not installed, and we're struggling to install those. So but they were given to us, they were donated. Yeah, so our tank experience, new skills for the whole family. There's my youngest with a whacker plate and not really driving the digger, honest. So that's my experience.
No, that's fantastic, Juliette. And it's, yeah, when we met the other week and you were telling me about this, I was like, oh, this is an awesome project. It's exactly the kind of thing you'd like to do, particularly as it was built by your kids. I'm just assuming they built the whole thing. But
Yeah.
So if we got, if there's questions for Juliette, again, feel free to put your virtual hand up or stick them into the chat, and we'll come to you. I just wanted to come back on one point you made at the very start there, and about the importance of talking to people about their experience and trying to really understand those technologies that you're going to be putting into your property. So I think, it's fantastic to go and actually see a heat pump, and I'm sure presumably you learn quite a lot from that, and it clearly influenced your decision.
Yeah, totally.
So,
yeah, it did.
So if not, I'm more than happy to ask questions because I have plenty. Here we go. There are some, and now they all flick through, and I can't read them. It's quicker than I can't keep up. So it's a question around the sort of PV, and that actually was a question I had as well. So why did you decide against the solar PV in the end? Is that is that a permanent decision, or is that something you might come back to?
It's not a permanent decision, no. And I think just because we had the space in the garden, and we thought we'd give a go with these solar thermal panels because they were donated, and yeah, so we haven't ruled it out, and we would love electric car, and yeah, we're thinking of having solar panels definitely on the garage roof, so that we can have the electric car running using those.
Yeah, I mean, it's a sensible approach, isn't it, to sort of look at that whole system, particularly if you're looking at the electric car as well. I guess maybe it's something actually when we come to Justin later on, because Borough Happold did some work with us around looking at solar PV with heat pumps and stuff, and what's the actual benefit to that. And there were some interesting findings, so we can certainly revisit that.
I think also solar panels are easier to retrofit, whereas we couldn't have done the retrofit that easily with a ground source heat pump. So it kind of just made sense that at that time to do, and we got the renewable heat incentive as well, so we joined that scheme. So solar panels is something that we could get move to in the future.
That's perfect. And as you say, retrofitting it is much easier, and it sounds like you've probably considered it in the design of your house anyway. It's facing the right way, for example. Cool. Where did you get advice on the approach? So when you were looking at ground source heat pump, air source, I mean, you visited site, but did you get advice on top of that as well?
So we actually contacted the Kenza, and they put us in touch with their local installer, and their local installer kindly arranged for us to see one of their former customers. So yeah, via the Kenza heat pump installer. And the researching on the internet was just my husband pretty much, yeah, just interested in that kind of thing and that kind of technology. And once we made the decision to go for that, we just then started researching how we go about it, and watching lots of YouTube videos.
I mean, you have a very strong background in research as well, so I guess that does help. On sort of coming to the renewable heat incentive, did that heavily influence your decision in terms of technology or whether you do it at all, or was it always a conscious decision to do it no matter what?
Sorry, can you say the very first bit again? I was reading the question.
Sorry. It's just about the renewable heat incentive, and did that influence your decision significantly in terms of A, doing it, and B, which technology you selected?
I wouldn't say it influenced it massively, but it was a big help to have that. And we hadn't planned to actually build a house. We were looking for a bigger house from our 3-bed semi in Plumpton, and we couldn't find what we wanted. So we broadened our area we were looking in, and then we broadened the idea of looking for a project. And then we drove past the water tank, which was at auction. So it was a kind of slightly crazy, educated guess that we would be able to get planning permission to build a house, and then it just kind of went on from there. I
mean, that's quite a change from your standard house hunt, isn't it? Admirable, absolutely.
It was actually my second attempt at house hunting. The first time that we tried to do house hunting, we gave up, and I ended up buying that boat behind me instead.
Spend a night on a boat, I suppose that works. A couple more quick questions. So, is the ground source heat pump definitely too noisy for an inside installation?
Not definitely. It's kind of a commercial freezer noise. But if you were to have one inside, I would just have sound insulation around it and think about the flooring and things so that you can insulate the sound as much as possible. So I wouldn't say definitely too noisy.
So not a deal breaker, but definite consideration. And then final one from Claire: could you link the solar heat into the same water tank, or is the difference in temperature an issue? So
I think you need a different water tank. So our plan was to have one for the solar heat for hot water.
So separate tanks if you decide to retrofit, or the issues with the thermal panels can be rectified on the installation.
Yes, yeah.
Awesome. Look at this, we're running to time, which is fantastic, but thank you very much, Juliette. That was really interesting, and amazing project. Really cool thing to see developed throughout, so well done on that. So the next speaker is George Gillow from Kenza, so taking a bit of a manufacturer's perspective, and lots of information around ground source heating in particular.
Afternoon, Dan.
George. Hi there, George. How you doing?
Yeah, and thank you very much for Juliette for speaking so well of Kenza. I'm glad it was a good experience of Kenza that went before me.
I thought it was a seamless transition, really, wasn't it?
It was.
Like it was planned.
Right. Can I share my screen? Okay, can you see my first slide, Dan?
We can, yes, perfect. Thank you, George.
All right, okay. Right, so I work for Kenza, as I was just explaining to Juliette. Kenza has been making ground source heat pumps in Cornwall for the last 20 years. And I work for the part of the company, Kenza Contracting, which designs, supply and install larger systems. So it's unlike Juliette, it's a shared ground loop is generally what we do. So we have a number of boreholes linked together to supply the low grade heat for a number of individual heat pumps in separate houses or flats. So just very basically, back to the very basics, we get 3 separate loops for a ground source heat pump. You have the cold side, which is indicated by the blue liquid on the right hand side. As Juliette says, it's a glycol, and you can see the slinky array that goes around the garden, which is kind of 1.2 meters below the surface of the ground, picks up the heat from the low grade from the ground into the first heat exchanger of the heat pump, and that transfers the heat to the refrigeration circuit, which then in its cold state turns into a liquid, just as we heard in the thermodynamic Plymouth example earlier. So it turns into the gas, which then goes through the compressor, gets compressed, and can heat up to 65 degrees, which is then transferred to the hot side, and then into the heating, space heating at 35 or 45 degrees, or hot water at 65 degrees. So my dogs just decided to start barking. So you can take the heat from a number of different sources. As in Juliette's garden, you can take it from the horizontal slinkies, or if you've got less garden space, you can go vertically down to a borehole. The boreholes can now go down to 300 meters deep. It's in the northeast of England. We've now got drillers getting down very, very deep. Over 500 meters is to be considered deep geothermal now. So this is still solar energy, which is collected and stored into the ground. And then we can have open loop systems where we can collect the heat from an aquifer or mine water or seawater source. So there's many different ways you can get the low grade heat for the ground source heat pump. Obviously, the main advantage of a ground source heat pump is that it's very, very low carbon. This uses electricity, which, as we can see from the renewable energy that is being produced at the moment, producing electricity, the majority of electricity is now produced by renewable means. Today, it's a nice sunny day, and when the wind's blowing, you're getting well over 50% of the country's electricity made by renewable sources. So this is why an electric appliance, such as a heat pump, is a very low carbon way of heating your homes. How good is the heating? Well, this graph here kind of gives you an idea of what the performance is all about. We talk about coefficients of performance for heat pumps. It's very important to understand what a coefficient of performance does when you're measuring different heat pumps, because you will have an air source heat pump, which may tell you it's 500% efficient, or a COP of 5 or more. And when we talk about ground source heat pumps, we talk about kind of around about 300% or a COP of 3. The important thing to remember is that those figures are an MCS regulated figure. So with a ground source heat pump, they talk about a 0.35, and that means the 0 is the ground temperature. So you've got a ground inlet temperature to the heat pump of 0, and an external an output temperature of 35 degrees, like you would have for Juliette's underfloor heating. If you have a higher temperature in the ground, so in the southwest, we've got an average temperature of around about 11 degrees in the ground. So you're taking a lot more temperature out of the ground. So this on the graph, as you can see, the inlet temperature, if you've got around about 6 to 8 degrees, taking out into your glycol mix, you're getting COPs of between 4 and 5, and that's where you can get some real efficiencies. The efficiency for hot water, because you're taking it up to 65 degrees to get over your Legionella's problem, comes down to around about 3 or 300%. But it's worth remembering that those efficiencies are constant with ground source heat pump. That's really the key thing, and the most important thing to remember. With the ground source temperature, your ground temperatures are constant throughout the year. An air source heat pump will fluctuate, and the National Grid is starting to understand if you have lots of air source heat pumps, yes, it works very well at low temperatures, but at certain temperatures, at 0, the air source heat pump will freeze up. And then it needs to turn into a little electric heater, a direct electric heater, to unfreeze itself. So it can cause problems on a large scale. It's not just Kenza talking about this. This is a study of efficiencies done by the Greater London Council a few years ago. So it's kind of independently verified. So that's kind of the basics of a heat pump. And then when we look at it on a very large scale, so certainly in new builds, we are putting in, I just went to see a site this morning where in Cornwall, we are installing heat pumps into a new development of 140 homes. There we have a series of borehole arrays, which will one borehole will supply kind of 3 or 4 properties. And the boreholes are connected together and then connected to a subterranean manifold where you can isolate each individual property from arrays. Some of the big advantages of this compared to a traditional district heating is there's no heat losses. So you can put these boreholes wherever you like. The further away from the houses they are is not a problem. It doesn't lose any heat. In fact, it only gains heat. You can do it for just a few properties, or you can do it on a very large scale. So if you're building new towns with thousands of homes, you can still do the same the shared ground array. There's a diversity factor as well. So unlike Juliette's single house in the garden, where you'd have one borehole, if you have a number of boreholes for a large amount of properties, it can be cheaper because they don't need to go as deep. Let's see on my next slide. Oops, sorry. So this is how it actually looks inside the house. You can see on the left-hand side, we've got a Kenza 3 kilowatt heat pump with a traditional cylinder above it. That's an unvented cylinder, hot water cylinder, specifically for a heat pump. They are slightly larger to have a larger coil, but it's a traditional system which would fit inside any normal sort of airing cupboard in your house. That's kind of would have a footprint of around about 1 meter squared for a 2.4 meter high ceiling. You can put the heat pumps on the ground floor. As Juliette quite rightly says, it's important to locate them properly on a solid floor. One of the noise issues you get from a ground source heat pump, it's not actually noise, but it's the vibrations. Because it is a compressor, just like you would have in a fridge, it does make that noise through a compressor. So if you have it on a solid ground floor, such as a concrete screed floor or a solid base, you can put them on a couple of inches of concrete paving. That will deaden a lot of the problems you get from vibration noises. But certainly we're putting them in internally in houses, in flats, and in houses. It's a very low running cost. Some of the real benefits of a ground source heat pump is the no statutory service. You don't need to service it like you would do a gas boiler. It's unbelievably cheap. At a 300% efficient system, electrically powered, it's as cheap as gas is at the moment. You don't need to service it at all. It will last for around about 20-25 years is the lifespan of a ground source heat pump. The ground array in the garden is just MDPE pipe, which is the same pipe that the water industry use to have your mains water. So that lasts for around about 100 years. It doesn't degrade very easily. There is no mechanical plant in the ground. It is just glycol filled liquid in the pipe, which circulates around from your heat pump. So the little circulator in the heat pump will draw as much heat as it is as required. That's a borehole. You can see in the middle there's a borehole there, which is 150 mil diameter hole, which will go down typically around about 180, 200 meters in most instances. But as I said earlier, we can go to around about 300 meters now. You can see the model of a block of flats behind. That's a model of a 403 flats in Enfield, North London. A recent development we finished for Enfield Borough Council, taking out gas boilers and putting in individual ground source heat pumps throughout the flats. 403 flats, the UK's largest single installation of ground source heat pumps. It was 8 tower blocks of 12 stories high. That's kind of the rig on the left, which drills them down. We do a lot of retrofit installations, and it can be a little bit noisy when they're putting them in, and it can be a little bit muddy, but it is relatively quick. The drills are in and out within a couple of days. One of the very important things about ground source heat pumps, and will become more and more important in the future, is that they can offer cooling as well as heating. As climate change is developed and the role of new buildings require more and more efficient and airtight buildings, overheating is going to become more and more of a problem. A heat pump can offer cooling in 2 different ways. It can offer a passive cooling, which basically takes the cold liquid from the ground and puts it straight into a fan coil unit in your house, or you can order the heat pump to mechanically make the cooling from the factory. So basically, when you get your heat pump in your house, you can switch it to a cooling mode, so it kind of reverses the system inside the heat pump, and it takes the heat out of your house and puts it back into the ground array. One of the very interesting things about taking heat out of buildings and putting it back into the ground array is interseasonal storage. So if you imagine, we are putting a lot of systems into commercial uses at the moment where they have a large cooling need, such as data centers, which have large computers which need to be cooled. We use the ground array to take the heat out of the computers or data centers, put it into the ground to use it for heating for the flats upstairs through the winter months. And this is kind of a really important part of what our research and our R&D at the moment is the interconnection of cooling and heating. It's a good it's a good reason to remember why we are doing this. Something I found on the BBC just recently was a 4-year-old boy in Cardiff having his story read to from his mum. And the question he asked was, are we going to become extinct like the dinosaurs? And the important answer is, well, not as long as we look after our planet properly. And I think really fundamental to what I do is coming back to the fact that we really have to remember of why we're actually doing all of this, why we're going to take out gas boilers and put something in that isn't taking the carbon out of our planet. So this is where we come on to what the government are planning to do to reduce CO2. And their plan is to get 600,000 heat pumps a year put into the domestic residential sector. That is a big ask, because at the moment, Kenzo, the UK's largest, we are making around about 5,000 heat pumps a year. We've just made a factory that's going to make 30,000 heat pumps a year, but it is a large jump to 600,000 heat pumps. That's a mix of air source and ground source. This is quite a complicated graph that shows the amount of electricity we might need. It's worth remembering that a mix of air source and ground source is going to be important as the future develops. I know Regen are in on this presentation today, and they recently did a report which shows a good mix of ground source and air source heat pumps will be important in the future to keep the amount of electricity required to decarbonize heat is kept to the minimum. And one of the main reasons for doing that is keeping the cost down for everybody. So the cost of a ground source heat pump to the householders, an interesting graph on that one, it's flicked forward, but the main thing to remember is that it's 300% efficient. And if your electricity at the moment is around about 15 pence a kilowatt, it's a third of that. So it's 5 pence a kilowatt, and that's going to be coming down as the future goes on. and we are allowed to use load shifting in the future. Controls for a ground source heat pump in standard housing is exactly the same as you would see in your normal central heating system. So it doesn't need to be anything that you need to be scared of, or it doesn't need to be complicated. It can be used for radiators as well as underfloor heating. And of course, it will get up to 65 degrees hot water. So I think I've just got to nearly my 15 minutes now. Just wanted to show you some of the things we've done in the past. This is a site for Hanover Housing Association near Ipswich, 22 flats, retrofitted. These were around about £13,000 per unit, just talking cost, but that did replace their central heating system as well as the ground source heat pumps and ground array outside. Some very nice testimonies from some very happy customers where we were replacing their heating systems. And that's the Enfield Council flats which we talked about a bit earlier. So I think I'm nearly up now, Dan, so I will just forward on some of my final.
That was fantastic. Thank you very much, George. Really appreciate that. And yeah, some really interesting insight there into some of the projects and things to consider. We'll take a couple of questions just because I think there's significant interest in that area. One question for the geologists out there: can a borehole be located in any geological rock?
Yes, the geological rock has different thermal properties. So down in the southwest, granite is a very, very good rock to have a borehole in, since it gives you a very good thermal conductivity. One of the only places where it does become difficult if you have artesian water pressure can cause a tricky situation when you are drilling through the non-porous substrata, and then you get a head of pressure of water, but even those can be mitigated.
So it shouldn't really be limiting in people's thinking around this.
No, not at all.
Perfect. In terms of borehole costs, what is a typical cost for a borehole? And I guess that depends on the installation, but let's take the example of a residential one for the purpose of that. Bill, please correct me if I'm incorrect in assuming residential there.
Yeah, that's absolutely fine. I mean, it's certainly a part of the industry that is very important and critical. On new build properties, for a typical sort of 2 or 3 bedroom house, we're looking at an installation cost of around about £8,000, and that would be for the ground array and supply of the heat pump and hot water cylinder. It's kind of ballpark figures, because, as you say, it does vary immensely because the type of geology, the location, the type of house you're going to have. So if you're going towards the very energy efficient end of the passive house style and very low heat loss, your boreholes aren't as deep, so it's a lot cheaper. So if you're saving money or spending extra money on energy efficiency on your house, you won't need to collect as much heat from the ground. Also, if you are having underfloor heating, your heat pump's not going to do as much work as if you need a higher flow temperature for radiators. So there's a balance to be had.
Sure, and there's a couple of examples there in your slides as well around the costs. So I guess we can draw upon those as well.
The important thing to remember about cost, cost is a big issue. So, cost on day one certainly is one factor that everybody has to think about. But lifetime costing, the cost of your heating, the cost of CO2 to the planet, all of those things, it is an issue that you have to bear in mind when choosing your heating system.
Absolutely, yeah. I think that's something we can draw upon a bit in the panel discussion as well. So I'll move on to Justin there. So thank you very much, George. That's really helpful. And some of those questions we didn't get around to, we'll try and revisit at the back end of this presentation.
Thanks.
Thanks, George. So if we move on to Justin from Borough Happold, who've been doing some work with us on the SunPeople project. Hi, Justin. How you doing?
Good afternoon, all. Nice to see you all, and thanks for the excellent presentations before. I'm going to focus a little bit on the work that we've been doing on the SunPeople project, but specifically building on some of the questions around what should I be thinking about for my building installation, and what are things that I should be considering before going and think about replacing my gas boiler with a heat pump. I'm just going to share my screen, so hopefully that will come up. And George, that was perfect actually, just to set out some of the technology part of heat pumps. So I'll just be building on top of that, and we'll skip over that. So hopefully this should just come up now. Someone can give me a thumbs up. Great, Dan, thank you. So brief introduction. My name is Justin Etherington. I work for Bureau Happold. We're a global multidisciplinary engineering company, got about 1,800 employees, but we're global, but we like to work local, and we like to help all scales of projects. And as a company, we're committed to net zero, the net zero transition, and looking to be operational by April this year. We've made that commitment, and so we're trying to walk the walk of what we're talking as well. And I've been working with Plymouth City Council in 2013 to help the strategic thinking around decarbonisation of heat, specifically in the area. So the SunPeople project was really about thinking about heat pump retrofits between smaller scale projects, but we've also been doing some thinking in Plymouth around some of the larger aspects in larger projects. But this goes right down from the principles are pretty much the same, and building on what George has set out and the experience that Juliette set out in her description. I mean, they're all the same principles, just it slightly changes with scale of project. So going from a single domestic house, you've got the same considerations around heat pump integration as you do to a multi-story office. The Interreg project gave us a chance to think about the opportunities for heat pump integration, but as John also mentioned, the opportunity for solar PV or solar thermal to contribute to that transition. So there's a few key questions, and actually this is sort of, I've just edited this now because I think it's a really important question to come from. Do I need to insulate before I transition? And this is probably something that George has come up against many a time, and also Juliette, you met that in your project. And I think this is a really important distinction to be made here, is that you don't always need to. If you're building new and you can afford to insulate and you can afford to do these, then the more you insulate, the better. You will get a higher efficiency of your heat pump, as George was talking about, and that will reduce the amount of capital costs you need to put into your heat pump, and also increase the efficiency of its operation. But if your driver is to stop combustion, if your driver is to stop burning gas, then actually considering the overall cost on a life cycle basis, you can probably implement earlier than you might think. So we've looked at a sort of 4-step approach roughly around the building to think about, am I ready to transition to a heat pump? And that's the little very schematic drawing on the right hand side is, do I have a suitable heating system? Do I have internal space? Do I have external space to actually get heat into the building? And do I have enough power supply? And I'm going to walk through each of those steps now, just relatively quickly, Dan, to get you to keep you on your rigorous schedule. So the first step, assuming that you're committed to come get a heat pump, the first question you can do is, well, how does my heating work, and could I already be operating it more efficiently, and could I actually already be compatible for a heat pump? So heat pumps work best at lower temperatures, as George set out, and typically there's a bit of an incompatibility with existing buildings. So your gas boiler is designed probably and set by the plumber to operate at 80 degrees. It doesn't necessarily need to be doing that. Quite often that's just something that we've just fitted, and as an industry have become very acceptant that 80 degrees is the temperature that our gas boiler can produce, and therefore must. And so the first thing to do is, actually, in many cases, you might have already done some energy efficiency. You might have already installed double glazing into a property that didn't have double glazing before. So your existing system might already have some spare capacity. So what we've found from simulation and also some user testing, my own terraced house is operating at 65 degrees, and it did so all through this summer. And I've got normal radiators, and there wasn't a complaint from me or my other family members. So that was just me fiddling with the heater. And so in many cases, our existing assets can be operated differently from as they are at the moment. So the first thing you can do yourself is consider, how does my house work or my system work? Can I reduce the temperatures, and will I get any comfort in doing that? So the first thing for me to do is, have I done easy energy efficiency things that I was going to do anyway? Are there things like draft proofing that I could do that are relatively cost effective? Have I trialed actually operating at lower temperature? If you can get down to 55 degrees operation or somewhere in those realms, there are heat pump products out there for you. Now, George has already set out that the lower you go, the more effective it becomes, and I fully agree with that. So if you have underfloor already, great. The lower you can go, the better, but it's not the be all and end all. There are other ways of doing it. So check doing that. But as was mentioned in the first talk, you have to consider how your hot water is generated, because Legionella is a risk that can happen with lower temperatures. So that's something that you need to consider. The next step is, do I have enough space? As has been set out, a heat pump works by collecting heat from the outside. That can be through a variety of sources, and then use your compression cycle to turn that into higher grade heat that you use. So you need some space outside. You also then need to connect that heating system into your existing heating pipework. So typically that will be emanating from your boiler, where your boiler is at the moment. So without a major reconfiguration of your heating system, you'd need to think about swapping the boiler out and putting some component of the heat pump there. So do you have that space? And that's something that you can do by looking at your own house and thinking about where that is, or if you're a commercial property, thinking about how your system works. And that's a bit of self-deduction. The next question, which I'm not gonna dwell on because George set that out perfectly, as there are multiple sources that you can have. They can be air source heat pumps, ground source heat pumps, and air slinkies or boreholes, and there can be water source heat pumps, and that depends on the context of where your actual plot is. But in any of those cases, you need to be able to harvest that source, capture it, and then bring it into your building. And so those things need to connect together. The final piece, if you've passed through those three tests, so do I have applicable heating system? Yes. Do I have enough internal space and can see a sort of practical method of connecting this together? Yes. And external space? Yes. Do I have enough power? It's already been set out that heat pumps do add load to your electrical connection, but you can also already find out whether you need an upgrade or not. In more commercial buildings, quite often you might already have sufficient capacity in your connection, and you're not using as much as you have. So check your bills, see if you can find out what your connected load is, and you can consult that through your utility supplier. Should be able to give that information. If you know what your available spare capacity is, your heating load divided by 2 or 3 is about the load that you need. So you might already have that capacity there. If not, you would need to have a capacity upgrade, and in the Southwest that would be through Western Power Distribution. They've actually got a useful process to do that on their website that you can find. And as Juliette mentioned, a 3-phase electrical connection will likely to be required with anything a little bit larger as a heat pump. But all those sort of things are supported by Western Power Distribution, and they're also aware very much of their role to play in the deployment of the 600,000 heat pumps. And there's significant progress being made by our distribution network operators. So what next? If we get 4 ticks across those 3 things, I have got compliant heating, so I've got the space, and I've actually got the power supply, then you're ready to actually consider going and talk to some people. I think it's already been set out really well by Juliette, that suppliers are there to help. There's lots of experience that people have shared on the social media sites and that sort of thing, and YouTube, to actually people sharing their experiences. And suppliers are probably more than happy to give you a hand, because really they're looking for an installation themselves at the end of it. So if you've got those 4 ticks, you're probably ready to have a serious conversation. As part of our SunPeople work, we have actually set out this form on the right-hand side, which I'm sure John will be able to circulate, which just sets out some of the key questions that are really helpful to try and put together for an installer to come and think about when they come around and have a look. But if you don't have 4 ticks across them, you know, it's all's not lost. Engineering and these sort of solutions can always be solved. They just may be a little bit more expensive. So there's always scope to speak with a professional, and they can help you on that journey. But one thing that we have recognized through our study is that it depends on your driver of what you want to do. But if you're committed to try and get off burning gas, then you can probably do it a lot quicker than you think you need to. And in terms of when you compare it in a life cycle sense, it may be more effective to make some compromises on the operating cost rather than the significant disruption you might have of a large-scale system change. And so there are some compromises that can be made. That's a bit of a whistle-stop tour of the considerations that you might need to make about your building systems, and I'll leave it at that. So thanks very much.
That's fantastic. Thank you very much, Justin. And yeah, really clearly sets out the sort of process that people can consider when they're deciding whether to go for a heat pump, which is fantastic. And I guess sort of looking back at the other case studies we've gone through there, they all tie in quite well. And the heat pump ones may focus a bit more on the space heating element, and then what James is talking about much more than domestic hot water. And ultimately, you know, we're going to need a combination of all of these technologies moving forward to achieve these zero carbon aims. So again, feel free to put questions in the chat. I got one from Noreen here. Can air source heat pumps connect to internal heat blowers if the wet system is old and in need of replacement? So, for you, Justin.
I mean, I think, you know, possibly the challenge that you have is what the temperature was that those heat blowers designed for, and therefore, if you connect a heat pump, can you generate adequate temperatures to meet the worst case heat loss time? You may also ask in that situation, do you need to remain with heat blowers? I mean, they're a technology of a time, and if they need replacement, is it time to make a more consolidated investment and maybe change your heating system? Possibly.
And sort of connected to that, actually, also from Marine, would it make sense to put an air source heat pump in a sunny south-facing location rather than a north-facing site? So this is an air source heat pump, I believe.
I mean, you could encourage some more local heating through solar heating through that to raise the ambient air temperature. In general, you're moving quite a lot of air with an air source heat pump that are on the colder side of the air temperature. You may not get as great a benefit, but every little helps. George, do you have any thoughts on that?
Yeah, I think the important thing to remember is that when the sun is out, you generally don't have your space heating on. So, you know, the air temperature is not really a massive consideration. You know, when you really want the heating on and working well and efficiently is in the long, cold, dark winter nights through the winter. So, you know, it's ground source heat pumps is not a heat pump for every location. But you know, it is a most efficient system that is going to work very well in the majority of situations. So, and just one point on temperatures of heat pumps. We talk about the ground source heat pumps we've got are able to get up to 65 degrees, but in commercial heat pump terms, so anything sort of over 500 kilowatts, they use a different refrigerant. So then they can get up to 70, 80 degrees temperatures. So for a hospital situation, for such a thing, you have an ammonia heat pump. They're built in situ, and they can get up to high temperatures. So, you know, there's lots of different things that heat pumps can do.
Yeah, I'd also just jump on the back of that one, George, that actually that heat pump temperature consideration is something that the market is really responding to, as they recognise the challenge of retrofit that's coming and developing. And so I think there's some fantastic products that you guys are making, and congratulations. It's really great to have such a good product out there. But there's some great moves in the air source area as well, for areas where that's not applicable, where higher temperatures are being generated at really quite competitive efficiencies as well.
Perfect. And I think sort of coming back to that original question as well, in terms of being directly south-facing with the sun, if you've got thermal panels and stuff like that, it starts to make more sense. You know, they don't have to be south-facing, but the efficiency does increase considerably. Whereas an air source heat pump, ground source heat pump, you're not gonna have much change. I think we'll take all other questions into the panel.
Dan, could I just add, we've got a site in South Wales where we're using PVT panels in conjunction with the heat pumps. So the solar thermal panel will use the heat from the summer months and put it in the ground array, and that produces an interseasonal storage for use in the winter.
I think, yeah, those kind of combinations of technologies are really interesting, and you know, it's hard to not get too carried away about, you know, making it too complicated and, you know, just try and focus on one thing. But where you can, yeah, when you can really understand your demand, particularly in commercial, and there's very clear, say, hot water demand, it's seasonal, or very clear space heating demand, which is very seasonal, then combining those technologies seems to start to make a lot more sense. So if we'll have to have a rapid fire panel discussion, and we'll go on a bit beyond 5:30. You know, I'm not in a rush, but please feel free to log off as and when. I appreciate we'll overrun a little, but I think there's some really good conversation to be had. So John Selman from Plymouth City Council is going to host the panel discussion, and on the panel we've got Mark Howard from Regen, and George, you mentioned some of the work you've been doing in Regen, so I'm sure Mark will touch upon some of that. David Lewis from Southwest Energy Hub, and we have got Alistair Mumford as well from Devon County Council, who've also worked very closely with as part of the SunPeople project. We've had lots of discussions around both residential and commercial heating options there. So if John, I'll pass over to you to host that part, and I'll keep track of questions in the comments box as well.
Thanks, Dan. I apologise if I've got some background noise. I've just got scaffolding going up for some solar panels on the roof, solar thermal. So very a lot of talk about solar thermal in the last 5 minutes. Thanks to all the excellent presentations so far, and Dan's obviously welcomed the panelists. Yes, Dave Lewis, who's one of the panelists, has to leave at just after 5:30, but if you could please type in any questions that you have in the chat box, or put your hand up, we will try to pick up. Obviously, a lot to digest in the presentations. You know, heat pumps come in all shapes and sizes. Definitely here to stay, according to the Climate Change Commission, and we're waiting for the government's heat and building strategy to be published finally, whenever it is released, maybe later in the next couple of months. It was due out in March, apparently, so that should hopefully give more support to heat pumps, which is desperately needed because RHI is rolling to an end. So we've got one question in from Noreen, which is, what financial incentives are currently available for retrofit renewables? I mean, presumably talking about heat pumps and solar, I assume. So I don't know who wants to kick off, whether David Lewis?
Yeah, I could take that one, as I've got a lead pretty sharpish. So the short answer is not very much. There is the non-domestic renewable heat incentive that is still available until March 2022. We did have the Green Homes Grant voucher scheme that was obviously pulled by government only 2 or 3 weeks ago. So the answer is not enough, and as John has alluded to, we are waiting to see what the future is with support for heat particularly. But you know, us pushing with bays has not eluded any hints about what is going on at the ministerial level on that at the moment.
Hopefully there will be some announcements soon, particularly as we work towards COP26. But I don't know, Mark or Alistair, if you have anything to add or on that particular question.
So just so we are expecting a short follow-on from the domestic RHI. I think it's 2022 to 24 with the Clean Heat Grant. I believe that's still in the offing, which very short term, both well, in many senses, but does offer a slight improvement in some ways on the RHI of being upfront money towards heat pumps. But that's posited, I think, to be a £4,000 upfront grant. I haven't heard any more than that lately. I don't know if anyone else has.
I think it was supposed to be talk about it launching March next year. Is that your understanding as well?
Yeah, as a sort of a brief 2-year follow-on to the RHI, whilst other plans are made. It's my understanding, which may be revealed in the, as you said, the upcoming heat and building strategy, which we're hoping for maybe next month. Rumours have it.
One question from Dan. Where would government subsidy be best placed for heating projects? On the retrofit or heat generation? Any takers for that, for the question?
Good question, Dan.
Yeah.
I think Dan should answer the question.
Himself. Because we put some thought to this.
Yeah. I think, well, the first one, I think we need a carbon tax. We can't just keep relying on subsidies and incentives. It's got to be a carbon tax, really. I think that's the best. My feeling is that's the best way of making these things better. And also, I don't know, it was interesting. I've forgotten the colleague from, or the person from Bureau Happold who was speaking earlier on about this whole level of efficiency you need to do. Because it's been embedded in my brain, really. The efficiency is where it's at. You've got to get that consumption down. But maybe it's not. Maybe there is a sweet spot, but then we'd have to try and find out where there is. But my gut feeling would be efficiency needs to have the more subsidies to go towards, really.
Yeah, it's our feeling at Kenza that a lot of the subsidy needs to be directed at growing the market, growing the industry, because at the moment we've been making ground source heat pumps for the last 20 years out of bits and pieces we can get from the refrigeration industry. Until the market is grown to such an extent where there is supply chains encouraged to actually manufacture the bits and pieces to make huge numbers of ground source heat pumps or air source heat pumps. That's when you'll see the cost coming down. And so we're really seeing, would be really good if government could direct incentives, maybe, at the infrastructure of heat pumps. So, with ground source, grants to encourage the third party, like for the gas industry, you've got a gas network, which is owned by Wales and West, which is owned by an American infrastructure company, and they make profits quite happily for their owners. I mean, why can't we try and develop something like that? That would then, encourage the use of ground source as well as air source. It's, it would be directing.
Justin, you thank you, George. Justin, you had your hand up earlier.
Sorry, I don't want to crash the panel thing. Just Alistair, just on your point there. I mean, I think what was interesting about the studies is just when you look at the cost of external insulation, wall insulation, those things, and the complexity of it. If your driver is to not combust, then your life cycle costs, you can come to the actual efficiency that you compromise can be more competitive than you might think in the first place. But it does mean that you're willingly stepping into having a slightly lower efficiency than you might be expecting on your heat pump. So it's a part of an overall consideration. But that's why I think there's a big this is why there's a distinction between what you do with new build, which is a no-brainer, and actually how far you need to go with the retrofit aspect, because not everybody has that much capital sitting around to be able to do that. And that's where the support needs to be.
Okay, any other thoughts, panelists, on either of those points?
I mean, I guess, say, depending on your drivers, the acceptable level of heat pump efficiency is often driven by what the resultant cost per kilowatt hour of heat is, which and the acceptable level of that is then driven by your alternative, your counterfactual, so the price of gas or the price of heating oil. So that winds back to the point that Alistair made, which we've made a few times at Regent, about a carbon price on heating fuels. So, which can be challenging, but if the price of gas is very cheap, and if the price of heating oil is very cheap, then a sort of less efficient heat pump them becomes less appealing. But you can, I used to fit heat pumps, and I've fitted heat pumps in granite uninsulated buildings on Dartmoor, and they work well, and you can put a high temperature unit in. You can not choose the radiators, you can put a high temperature unit in, you can get good satisfactory performance, but you'll get an SPF, so an annual performance of maybe 2. If you're prepared to accept that as a customer in terms of the sort of unit cost that gives you for heat, and if your network operator is able to supply you an appropriate sort of power supply, especially out on Dartmoor, that can be challenging if you're at the end of a line. You can do that and you can deliver it. So often at the moment it is about what the counterfactual cost is and what people's drivers are and what they're prepared to accept. But absolutely, as Justin said, get an engineer on the solution and you can deliver it. But it's about what your acceptable sort of parameters are within that box. And certainly for mass solutions, we need to be bringing down costs. We need to be making it more competitive. But definitely at the moment there are, you can solve that problem.
Great. We've got quite a few questions coming in, just conscious of time. One of which ties into your question mark around, or your point around cost coming down. From Didier says, will costs come down when the market will need to supply 600,000 units per year? So will we see a reduction in the capital cost, which is currently sort of obviously significantly higher than your average gas boiler? Does the panelists see this cost coming down with volume in terms of the market?
I'm happy to chip in a little bit again there. We've looked at this a little bit for one of our recent papers, and there's definitely scope, as I understand it, for capital cost of the appliances to come down with mass manufacture, and that varies across the type of appliance and how they're manufactured at the moment. There's a lot of scope for installation costs to come down, and that's partly to do with simplification of equipment and making it easier for installers to turn up and fit. You can change a gas boiler over in a day, and a heat pump can take quite a bit longer than that, often because the market's just a little bit different. Those specialized components aren't fully integrated. So more integrated solutions can help reduce those installation costs, as well as a bigger market. Cost of sale. I know that George, I've spoken to before about the cost of sale, the number of people you've got to speak to, the hours it takes to sell a heat pump, and having been in the industry myself, I know how long it can take.
Yeah. So
those things can all improve the market situation for bringing down costs. There will be a threshold ultimately. Someone made a really good point the other day that the amount of raw materials in a heat pump will remain higher than those in a gas boiler. So there will always be a bit of a cost differential in there. I think it was a chap from Valent who manufacture boilers and heat pumps and pointed out that a boiler weighs 40 kilos and a heat pump weighs 100 kilos. So the amount of metal that goes in will always drive a slight difference. But I think there's a lot of scope to bring costs down. Yeah.
They do last twice as long though.
You got a good point, George.
I think what's interesting about this is, this expectation, I guess, from a consumer perspective that we're conditioned to have, which is that we can make a change and it will be more cost effective than what we've got at the moment. And that's one of the sort of as Alistair was setting out and yourself, Mark, is that that's where the carbon tax and the other mechanisms need to come in to support that, because the fact is you can drive all these improvements, but where we're currently the current position is it's not a simple consumer cost driven change. People that are doing this either have the opportunity, as Juliette did, to start from, this is a project and I'm going to build it into the project, and that's the opportunity cost at the beginning. But if you're just looking to make a switch, you suddenly got to take on a project, which is different to as you said, the boiler industry, which is just there to say and catches people because they're absolutely vulnerable. Boiler fails, and then they've got the most cost-effective solution, which is £2,500 to come and whip it out and put the next one back in, and that's what really needs to evolve.
Yeah, well, I hadn't realised until recently that gas boiler installers get commission So from the manufacturers. So I mean, there's obviously no incentive for them to suggest anything other than a gas boiler, is there? But yes, I come back to another question. Adrian White, do ground source heating become less efficient at the end of a long cold winter? The fact that you can store heat underground in summer implies the ground temperature can be quite variable. So this issue about, I suppose, you know, how to what degree you can store heat, I assume.
When you design to MCS standards, you design it so it doesn't go below 0 over after 20 years. So over a season, you wouldn't notice the differences in ground temperature. Really, the ground temperature comes from the amount of sunshine that's on the ground. So, but you wouldn't notice it in efficiency terms.
Okay, hopefully that answers your question. I was conscious of time again. And this is, so Noreen has posted another question, which is, what's the panel's opinion and experience of combined solar PV and battery storage in terms of efficiency and system cost? Is this in relation to use with heat pumps? I assume in terms of, because obviously SunPeople is exploring solar and heat pumps, that combination, solar thermal, solar PV. But I suppose it'd be good to get your views. David, perhaps, do you have a view on this? Or...
Sorry, just about got to go, Mr. Salmon. Sorry, and I was busy typing into the panel there to say I have to leave. Sorry, which question are we? I'll give you a quick response. Which question were we alluding to?
Sorry for putting you on the spot. I know you've got to brush off. So basically, what's the panel's opinion and experience of combined solar PV and battery in terms of efficiency and system cost? I mean, it's perhaps not main focus around heating, but
no. I think again, this all depends on fit for purpose. I think a lot of batteries. I was reviewing some projects for community projects for Somerset County Council, and a lot of batteries were being sold on top of PV, when actually their profiles or when they required them didn't require a battery. So I think buyer beware. It is fit for purpose. If you're going to be using a lot of your energy or your power when the sun is not shining, then it makes sense. But I think again, it's looking at that cost benefit of batteries, and personally, unless you have a direct need, and where seeing other installations, if you are at that remote, I know colleagues of mine installed solar PV and heat pumps. It was a very remote, large building. They often got cut off. They were at the end of the grid, and so batteries made eminent sense for their very large house that they had at the end of the grid. So it has to be looked at, and having that professional looking at it and having the right company looking at it to give you that benefit and to see if it is a cost benefit and of benefit to you for the power.
Okay, thanks, David. We'll let you go now.
Thank you very much, guys. Cheers.
Thanks a lot.
Cheers, thank you, guys.
Yeah. So, yeah, it's a question here from Dan. For installers, engineers, what would it help customers to learn? And I think what questions would you like them to ask effectively? So I suppose this is about making decisions. What sort of heat pump would work where? What does a good scheme look like? I know Justin's been through some of that, but any takers with the remaining panel members, Mark or Alistair, or we can ask open up if you want.
Sorry, John, just to add to that, it's kind of also, yes, sometimes consumers don't ask the installers, engineers the questions they might like them to ask, and they're very focused on certain elements. Price would be the obvious one, for example. So what would you prefer the focus to shift to? What would be nice for them to ask you?
That's an interesting question.
I'll let Mark think, because he can give a better answer than I can. But just on the things to look for, one of the things would be that they don't just send you a form for you to fill out with like numbers of radiators and where they are and things like that. I think it's critical that they come to your building before they give you any kind of advice. So that's definitely something I'd suggest there. And then there's the usual thing about getting 3 quotes. But I think in terms of, obviously, there's some good there's different technologies and have different price points and pluses and minuses. Kenza is one of the best you can possibly get, but yeah, so I think it's usual. But anyway, Mark, has that given you enough time to think of a better answer?
Thanks, Alistair. I'm
Thanks.
sure your book token is in the post from George.
Thank you very much. Yes, I'm happy.
Yeah, I mean, I think so. I spent a number of years in the industry doing sort of sales and installation, and I would say that I found the most important thing is always to understand what a consumer wants. So often you would get customers who are, because they're sort of early adopters, they are really, really focused on the technology, and actually it can be quite important to wind back to what you actually want. Like what are your outputs here? What are you trying to achieve? So like, when are you home? When do you need heat? Like, how much hot water do you really need? What level of complexity do you want from your system? Because you can get really, really complicated WYSI controls, which are great. My experience is that a lot of people don't understand a programmable thermostat, and that's not that, you know, from a smart controls perspective, that's not very complex, but most people really struggle with it. So I'd say a lot of it is about understanding what consumers want, and then sort of finding the best thing that fits around their lifestyle. So, you know, I used to sell, you know, do biomass boilers as well, and I spent a number of hours trying to not sell log boilers to people, because it looks like a great solution, but they're really, really inconvenient. So it's not the same as heat pumps, but I think getting customers to really think about what they want out of a system and how they'll use it and how much they really want to be involved with it is quite an important thing for them to understand. Less focusing maybe on those sort of technical things. That'd be my view.
Yeah, it is quite not baffling if you're just a homeowner or a building owner, just asking the right questions and knowing where to look for information, and not going to the first installer who might you know, rock up at your house or whatever. Is I suppose that's what we're trying to do through this SunPeople project, isn't it? Is try to sort of talk about best practice and key considerations, because it is quite challenging unless you're very technically minded or very enthusiastic and prepared to watch lots of YouTube videos or whatever. As I'm sure quite a few people on this call are, which is great. I don't think we've got any other points other than a point from a question, not really a question, a point from Kate. Surely at the end of the day, for the long term, we have to improve thermal efficiency of our buildings wherever possible, as they will have to be heated into eternity. I think that's just a point rather than a question. I don't know if there's...
It is a good point though, Jonathan.
Yeah.
You know, we are going to have to get to net zero, and that's a lot of wind turbines. And as much as I love wind turbines, there are other things on this planet that don't like them. So we do need as little of them as possible. And obviously we can't give any opportunity for more nuclear as well. So we massively need to reduce our energy consumption. And also to think about the, you know, over as George was sort of talking about in cooling, you know, the thermal improvements we're making need to be able to deal with the increased temperatures that we're going to be having in the future as well. So we need to be thinking about thermal mass and being able to deal with overheating.
Yeah, absolutely. And I think energy efficiency is a great example of that need for long-term policy to allow an industry to scale and to industrialize, because at the moment it's, you know, it's undergone decades of stop-start policy support through, you know, whatever funding mechanism, and that that doesn't support an industry and doesn't allow an industry to invest in itself and deliver solutions that end users want and can buy easily. And, you know, obviously the Greenhouse Grant was supposed to help solve this and has not. But yeah, I think improving energy efficiency is paramount for, as Alistair says, you know, for reducing demand of electricity, for improving the efficiency of the heat pumps or whatever other heating solutions we end up with. And that's where we need the, the heat and building strategy that will fix it.
It is a balance, isn't it, between trying to reduce carbon emissions quickly, you know, at relatively cost effectively, and trying to move as close to net zero as possible, particularly with retrofit, with the challenge. I guess we're kind of drawing towards the end, so I can't see any more questions. Are there any kind of, I suppose we can open this up to the speakers as well. Are there any kind of final reflections that you have, or have we exhausted all avenues
I think,
of
John,
exploration?
on my final thoughts would be that hydrogen is a big elephant in the room. And if you are thinking about decarbonising heat and electrification of heat, it has to be heat pumps, whether it's air source or ground source or any other sort, because the hydrogen, even the green hydrogen, is a 1 kilowatt swap. So 1 kilowatt of heat is produced by 1 kilowatt of hydrogen. And so the amount of electricity that you would need to generate is a ridiculous amount. I mean, don't even think about the blue hydrogen, which the oil industries and the gas industries are peddling, and that is just, you know, a complete misnomer. But you know, I think of the relative kind of 60% increase on electric generation is what people are in the industry thinking about as a reasonable target of increased electric generation for a heat pump based solution.
Okay, thank you, George. Any other takers in terms of as we round up?
I'd add to that. I think I take George's point, but I also think we need for a bit of pragmatism. That I think the debate is often very binary, and I think it won't be heat pumps or hydrogen. I think we'll have a mix and a patchwork of solutions, and we've all become very used to basically everyone having gas. And I think what we need to come to is that actually we'll probably have regional and local variation in heat solutions, and there will, in any of those scenarios, be a lot of heat pumps, but there will probably be a patchwork of hydrogen near industrial clusters and biomethane in other areas and district heat in urban localities, and that whole mix of technologies that will serve us, and how we thrash that out in a policy context and make sure we don't end up with inequality as to who pays different amounts for the heat that they get based on where they live is, I think, going to be a really interesting one to solve in the next decade or so. But yeah, that would be my add-on to that.
Yeah, and certainly the Climate Change Commission has viewed hydrogen as being really around shipping or large industrial plants, and the heat pumps being for the majority of domestic and other buildings, I suppose. But any other final thoughts before we wrap up? Alistair or Justin?
No, I'm okay, thanks.
James?
I just add, really support what Mark the statement Mark just made, you know, and I think, you know, it's quite, people get quite you know, attached to this is the only way, but you know, as James set out in the first talk today, you know, that's brilliant technology, creating domestic hot water for you, and heating for your property, and that's, you know, that's a different technology, and I say there are many ways of doing it, but making sure that it's one, technically correct, and also right for the a fair product for the consumer is where we need to get to.
Absolutely. So getting good information out there. So we're almost 15 minutes over, and I'd just like to thank Dan and Kat for organising, hosting this, and all the speakers and the panelists for contributing, and all the excellent presentations. And we've got lots of positive comments in the chat box from everyone. So we look forward to seeing you at the next event. And Dan, I think we will circulate all the presentations. And it's been recorded.
If all the presenters are happy to send them to myself or Kat or John, then we'll circulate those, and we'll make you aware of any other sort of resources that, as we develop them, we'll put them on the website, etc., and share them around. So thank you very much, everyone. Much appreciated. And yeah, look forward to seeing a few projects happening over the next few months, years. And we'll finish them by 2030. We'll be done then. That's fine.
Yeah.
Absolutely. Yes. Okay. Thanks, everyone. Take care.
Yeah.
Great. Thanks very much, guys.
Bye.